Hello everyone, in this section we are going to learn about convolutions. So since we are talking about convolution neural network, we need to understand a little bit about convolutions, and in a very easy and decoupled way, right? So basic convolution is an image transformation done using a kernel to extract certain features from one input image. On our case, and how this kernel work and how this transformation is done. It is basically we start with a kernel, and each let's say each feature that you want to extract would have a different kernel. In our case here, it's a 3 by 3 filter, let's say a kernel, and we apply this filter against each pixel value from our image. For example, we are taking this image here, this boot, and we want to transform this this pixel that today it's 192, and then in order to get a new value for this, focusing and extract a specific feature, we apply this calculation, which it is basically just take each item from our kernel and doing some multiplication plus equations, and then you get the image transformed. And for example, here you can see, let's take this image as an example, and I have created here one convolution function which will help us to visualize things. It's not very important, this function, so I'm gonna skip that. And so for example here we want to get an image version which will be highlighting some horizontal line. So we know that there is this kernel, and which when you apply this kernel to an image, we get this version of the image which will be highlighting some horizontal line. The same when you want to get a vertical line, so we have this kernel that you apply to our image, and then you get a version of it. The same when you want to detect some edge detection, we have this kernel, and you apply, and you can see it here. For applying blur, for example, we have this kernel, and you will have this version with blur applied. And it's basically that. So it's a transformation of an image that will have different kernel to extract different feature. And the beauty is when how people got to those let's say kernel, which would be after applied some calculation would highlight different feature from an image. That's the beautiful part, but to use those it's very simple, and you can see here in a more dynamic way, and on this website here, where you can see high level. First you can see the navigation picture by picture, and the calculation be applied in the middle, and we can also choose which feature you want to extract. For example, this is blue, this is the kernel values, and if you want a bottom low, you see the transformation, just change those value here, we get those. Look this one, and here some description why it's highlighting, so it is give a illusion of depth and emphasize the different pixels, and give a direction. And this identifies, so it looks, and you can navigate and see a different kernel and applied to the image. And it is basically that convolution. It's this transformation that highlight some feature that our neural net will be able to look at those to identify and learn from those. And the other thing that is part of convolution, it's pooling, and it's also a transformation on the image, but now it's not to extract a feature but to reduce the size of the image. And how that's done is basically get for 2 by 2 area, let's say, of the image. This, let's say the whole thing is the image, and you get 4 pixel, and we extract the highest the max value of this area and go sliding across the image and doing this again and again and again. So in this case here, get 192. On the other here, when you slide down here, you're gonna get 145, and in the end you're gonna reduce by half the size of the image without losing the characteristics of this image. And you're gonna be applying this here again. So for example, the original image is 500 by 500, and after applying this pooling, we reduced our image by half. You can see that now it's 250, and the image is still the same. So by doing this during our training phase, this reduces like drastically the time that it takes to train to train our model. So that's it on this lesson. So basically here you saw some transformation that will be seen, those transformations done by our neural net, but it's very important to look that individually and see that it's very simple, let's say, transformations. And basically during our training, our model would be keeping all those versions of our image in a, let's say, a three-dimensional array. So every feature extracted, it will be part of our, let's say, feature map. That's how we call our feature map. We will keep all this transformation for further calculation on the subsequent layers. We're going to be seeing those later when we are playing with neural net. That's it. I hope you guys have enjoyed, and see you next lecture.